Hello?
Hello. Hello, Ryan. How are you today?
I'm doing good.
That's good. That's good. How was your day today? What'd you do?
What I do? So I got
Yeah.
really bored and then I shaved my legs.
Oh, you shaved the legs from like the knee down or like the whole leg?
Just the whole leg.
The whole leg, dang. I see. That's good. Yeah,
Just
have
the
you ever
head.
shaved it before, or is this the first time shaving it?
First time.
Oh, I see. I see. Dang. Was it
Hmm.
like too hot or something, or you just wanted to shave it?
I just wanted to, because I was just sitting there and I kind
Yeah.
of just like did everything, just like from like working out, eating, like studying a little bit, and then I was like sitting there like, what should I do now?
Oh
And then
yeah.
I look like on my table and there's like a little razor and it's like F it and then I'm just gonna yeah.
So you shaved it yourself? Like your parents didn't like help you?
No, I just put some soap on it and then I
Uh-huh.
just did it.
Oh, I
That's it.
see. Dang. How long did it take you?
Like like 20 minutes.
20 minutes? Okay, okay. See, that's good. Yeah. You've been waking up at around 6 a.m. like you wanted to?
Yeah, it's always 6.
Or 6 now? That's good.
Mm.
Do you think you could keep this like same schedule but like sleep around 10, wake up at 6 like when you go to school? Like when does your school start? Like again like 8 a.m., 7 a.m.?
Yeah, school starts at 8:30 a.m.
Yeah, 8:30 a.m. So 6, is it that too early? Like to like wake up and do everything? Or like you, if you wake up early, you get to do stuff before school
I
to
get to do stuff before school and I get to eat before school.
yeah, yeah, yeah. That's right. That's right. Yeah.
Because like last quarter, I just did not even eat anything
Breakfast.
at all. And
Yeah.
like I would just wait till dinner and then not
That's
eat
the same for
anything.
me too. Like before, like I just woke up, get ready, go straight to school. But now I wake up a little bit early, and then I eat breakfast before going to school.
Uh-huh.
Yeah. Because like when you don't eat, sometimes does the stomach make like those loud sounds in class, like the growling sounds.
No.
Uh-huh.
Hmm. I think I had to like be like really starved to actually make those sounds.
Those sounds, yeah, yeah. But has that ever happened to you before in class? Like when your stomach makes those kind of sounds in
Uh,
class?
yeah, it did, but there was like a movie playing already, so it was like already covering it up, so.
Oh yeah, 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 yeah. I see, I see. Dang, it's good. What
Hmm.
did you study today?
Study?
Uh-huh.
Pre-calc.
Oh, pre-calc. Like, do you have the resources already, or did you just like search up random resources
I
online to study?
just did some exercise on Khan Academy.
Yeah, yeah, that's good. Yeah,
Function composition on like graphs and solving equations, and then that's it.
yeah, 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 I see. That's good. That's good.
Hmm.
Did you go anywhere outside of your house today, or did you just stay home the whole day?
I did stay home the whole day.
Uh-huh. Yeah, nothing
Like
to do.
waking up at 6 kind of did like just take me out. Just like I just like fell asleep in the afternoon, and then just like I just knocked out.
Knocked out. Yeah.
Mm. It really does suck when I feel really tired in the afternoon just because like I have work to do. Even like at school, it's like, no, I can't.
Oh
Please.
yeah. I know. I know. Like you try to avoid naps, so then you just like fall to sleep like almost instantly when you hit the bed at nighttime.
Yeah.
Yeah, that's good.
Hmm. What'd you do today?
So I woke up around like 4:30 ish. Wait, what day is it today? Today is yeah, Tuesday. 4:30 ish. To wake up, get ready, eat breakfast, and then I'm in this club for chiropractic school, called KTC, or Carol's Training Culture Club, where we exercise the muscles that are needed to like deliver adjustments to people. Um, we also practiced like the form of our body, the posture before giving adjustments, how to reset the body, like be present with the patient,
Mm.
so then the patient feels more at ease. So it's just something that I want to do to get ready when I actually do start working as a chiropractor. So that's every Tuesday and Thursday at 6 a.m. But the drive from my house to school is 30 minutes. So I wake up at 4:30 to get ready, eat breakfast, and then drive to school. And then 6 to 7:15 ish, do that club. And then 7:30 to like 5 or 4 p.m. depending on the day is when I have the school lunch breaks and everything in there in between. And then
Mm,
I like the drive home is like longer than the drive there because there's traffic like around 5 4 p.m.
mm.
So it takes like 40 to 50 minutes to drive back home. And then when I get home, I try not to take a nap, but then when I'm like so tired, I just take a nap for like an hour or something like that, or an hour and a half. And then I wake up, do some homework studying, um, eat dinner, walk my dog, uh, and then look forward to these office hours 9 to 10.
Yeah.
Yeah.
Hmm. I also forgot. I like finished like like 6 hours of like driving instruction, and like where just like the instructor just like sits like with you in the car and you just drive everywhere. Yeah.
Yeah. Is that
So
what
like
you did?
yeah. So right now I'm like trying to like appoint like a place where like to go to Folsom the Folsom DMV.
Oh, Wholesome DMV.
Yeah.
Dang. So are you finished with your 6 hour training yet? Or
Yeah.
oh, okay, okay.
So I'm trying to get my driver's license.
Yeah, that's good. And you're 16 right now, right? Yeah,
Yep.
yeah, 17 January. Yeah,
Mm.
that's good. I got my license like at 16 too, so or like around that age. Yeah, like you get so much freedom. Like when you once you get to drive like by yourself with no parents, like just by
Mm.
yourself, you get to go anywhere you want.
How many tries did it take you?
Oh, one try, but I had a lot of mistakes. But like not enough to fail. But I did pass the first try. But I
Oh,
did make a lot of mistakes.
all
Not
right.
major mistakes though. Like there are something called major mistakes. I forgot what they're called, where they give you automatic fail. Like
Yeah,
turning into like a wrong lane or like wrong direction. That's on the two-way
yep,
street, one-way street. That's an automatic fail.
yep.
Yeah.
Hmm.
My mistakes were just minor, but there were a lot of them.
I, th- I looked it up. There's like 16 minor mistakes, and there's like one major mistake you can make.
Yeah.
Yeah.
As is yeah, like the like under 18, like you could they uh allow only like a few mistakes, I think, and then over 18 there's like more mistakes. I'm not sure how the age thing works for the mistakes and how they test you. Hey Katia.
Hello.
Hello, how are you?
All right. How are you?
I'm doing fine, doing fine. How are you feeling so for your midterm this Thursday so far? Like, are you feeling more prepared or still more review needed?
I mean, I don't feel too bad. I started going over my notes and I think there's some answer key online for the homework. So I'm gonna start like going over the homework just to make
Uh-huh.
sure I got them right and then fix the ones I got wrong.
Right, right.
But I mean, I don't actually feel too bad, which is really weird for me with chemistry. So
Mm-hmm.
hopefully it's not like I feel good and then I end up doing bad. But
Oh
you know,
yeah.
how'd your quiz go?
It went okay, better than I expected it to be, but it could have been better because it was my fault. I could have like started studying for it earlier, which is like a learning lesson for my future quizzes and exams. But not as
Isn't
bad.
that always the case though? Like you
Yeah,
always could have started studying earlier.
earlier. Yeah, I know, I know. That's always the goal. And like we tell ourselves that, and then it gets too late. Like oh my god.
Yeah, I know. It's like I'll have 2 days to study. I'm like, not really though, because my test is on Thursday, and I like mentally in my mind it was Friday.
Yeah, I know. So a trick for that is to like think the test is like or the quiz exam is like earlier than it actually is. So then it like
Oh yeah,
puts that pressure on you.
yeah.
Yeah.
I was just like one of my main things was I just want to make sure that like if he asks us to draw resonance that I'm able to
Hmm.
draw all of them. And I was just wondering if you had any like tips for that
Right. So
or like
the
isomers too.
resonance structures, right? There could be a lot of them where some of them are going to be very minor, which are going to be like the ones with a lot of formal charges. Like let's say two negative formal charges, three positive charges. Those resonance structures are not likely going to be needed to be in the answer because those are very unstable and minor, right? So, for
Right.
example, let's say we have
I gotta memorize my choreo.
Choreo. Choreo acronym for strong base, or like a ranking system.
Yeah.
Yeah. Right. Okay, so how would you draw the major resonance structures for this molecule here? I mean, yeah, like the other resonance structures starting from this molecule here.
We could move the double bond to the oxygen, right?
This double bond to this oxygen right here, like this.
And then
Great.
it would move that charge.
So this is going to be a negative charge right here, right? If this is a negative charge,
yeah,
how many pairs of electrons does this oxygen have right here?
3.
Yeah, 3 pairs. It already has an octet rule. So when we try to make a double bond right here, that is going to break the octet rule of the oxygen. It's going to have 10 electrons. So we can't do that.
Oh, wait, can we move one of the electron pairs down?
Yeah, we can move one of the electron pairs down to make a double bond right there.
Okay.
Right? And then that's going to be a problem now because notice how this carbon already has an octet rule, 2, 4, 6, 8 electrons. If we try to put a double bond there, it's going to break the octet rule. So we have to do something. What do you think we could do to conserve the octet rule?
Could you move the double bond to the ring?
Yeah, you can make a double bond right here to the ring, right? But then that's going to break this octet rule of that carbon. So what can we do from there?
Oh, could we move the left double bond and make it negative?
Make a negative charge there, right? So that's the shortcut way to get to like the other end really quickly, right? But on exams, I do not recommend going all the way like that. Like this, right? Because we want to do it step by step to show all the feasible resonance structures. So this oxygen negative charge here can still make a double bond there. And this double bond, instead of making a double bond in the ring, we could put a negative charge on that carbon right there before making a double bond there. Right. So we do it one at a time to get to the other end, to put the negative charge on the other end. Right.
Okay.
Right. And then from that negative charge right there, then we can make a double bond here and then put that double bond onto that carbon right there to give that carbon a negative charge.
Okay.
Yeah, which gives us this resonance structure right there on the top.
Okay, yeah.
Right. And a tip for that is the resonance arrows. Notice how in the first one here, I drew out 3 arrows. That's going to be like skipping so many resonance structures for your answer.
Okay.
Right. It's most likely going to be 1 or 2 resonance structures only. Right. In this case, it's 2 because we're moving in negative charge here. Right. Another thing about resonance is that negative charges
move towards the positive.
Yeah, move towards the positive. The positive never moves.
The positive don't move.
Yeah, positives don't move. Right, positive, it's as a void. There's nothing there to move. It's an empty space. But the negative charges, think of it as electrons, and electrons are very like reactive.
Mobile.
They're very like movable.
Mobile.
Mobile. Yeah, mobile. Right, very mobile. Right. So let me give you another example here.
I was ready for that one.
Oh, you're ready for this one? Okay, let's actually do this one here. I'll tell you why I didn't want to do this example first. So let's try this one here. What would the resonance structure for this one look like?
Move the electron pair on nitrogen towards the positive charge.
Towards the positive charge, right? To make
up a double bond.
Double bond between the nitrogen and carbon right there.
Yeah.
Right, and it would give this resonance structure. Oh, this is actually good. Actually, luckily, we stuck with this here because what would be the major resonance structure? the left one or the right one?
It says what from my notes from earlier. It said you want the negative charge on the more electronegative atom,
Right.
but
The
we
negative
only
charge
have
on
a positive charge.
only positive charge, right? And then another way you can think about it is like the positive charge wants to be on the less electronegative atom.
Okay, that's what I was thinking. I was like, does that
Uh-huh.
track logically? Okay, so then it would be the one on the left.
Yeah, so that's why this is a tricky one, and this is why I'm glad that we stuck with this problem here, because there is one factor that overpowers any other factor, like the electronegative atom with the negative charge, the less electronegative atom with the positive charge. Do you remember that very like important factor that triumphs every other factor? The number one thing you look for?
Match the overall net charge on the original structure.
So think about all the atoms. They want the octet rule. So every single atom wants to have 8 electrons. This structure here, how many electrons does this carbon have right here? How many bonds?
Has just 3.
3 bonds. It's missing the octet rule.
Yeah.
Whereas in the right structure, all the atoms there have a full octet rule.
Okay, yeah, because I was like, I mean, like for me, it makes me happier because the nitrogen,
Yeah, I know. Yeah, that's why this is tricky because like this at first sight, this looks very unstable because nitrogen is electronegative. It does not want the positive charge, right?
Okay.
This one looks more happy, but the octet rule.
Okay, so octet and then minimal charges or no formal charge, and then the negative charge on the electronegative atom.
Yeah, that's right. That's right.
Okay, that's why I had it written down. I just didn't think I like mentally prioritized it in like,
right.
kind of
For the resonance stuff.
Yeah.
Yeah. Do you want to try more practice problems with these stuff and then move on to the next concept? I have a lot of them. I just gotta find them in my notes here really quick.
Sure, yeah. I mean, if nobody else has questions, or you're welcome to take other questions. So I'm here.
Ryan is just here just to watch because he's gonna take probably take OChem later because he's in high school right now. So he just found me like through YouTube and then he wants to like get a head start or something like that.
Wow, that's crazy. I do not have that kind of dedication.
He's gonna be ahead of the game when he starts.
Yeah, I was ahead of the game just by listening yesterday because that's what we started talking about today. I was like, R and S. What is R and S? And today we were talking about R and S.
Oh yeah, you haven't gone over R and S yet?
No, we just did today. Now we're on, now we're on chapter 6.
Yeah, dang, that's good. That's good. And you're like, oh, we went over this last night in office hours.
I know, it might make sense now.
Yeah. And, positive charge.
Were you talking about Ryan's driver's test?
Yeah, we were. He just finished a 6-hour training requirement because he's like under 18, so he's gonna like take it soon. Yeah.
Good luck. Take it at a good DMV.
Yeah. Make sure you choose a good DMV because the DMV actually does matter, like when you take the test.
People who took it, I know 2 people who failed it the first time at bad DMVs.
Oh my god, yeah. Did you pass the first time? How many tries did it take you?
So I decided to schedule my driver's appointment for my birthday. My 16th birthday because I'm a tryhard like that. And I was like, well, I'm either gonna pass and it's gonna be great, or I'm gonna fail and it's gonna ruin my whole day. Because my party was also on that day because it was a Saturday.
Oh my god.
So I passed and it was great, but I took it in Costa Mesa, so I pretty much just went around like a neighborhood residential block. I think I got like 1 point off because I didn't want to break, and it went from 25 to 20, and so I was going like 21 miles per hour for like a second too long.
Oh my god.
Yeah,
that's good. That's good.
Did you pass on your first time?
Yeah, I did, but I made a lot of minor mistakes. No major mistakes though, but I did pass the first time. And then one of the mistakes was like I was going too slow because I wanted to drive extra slow because it was a test in the neighborhood. Like I was going like 20, and then he was like, "Oh, you go 25." Like he was telling me to go faster in the neighborhood.
They should have given you a break. They're supposed to have like 5 miles an hour of leeway.
Oh yeah. Maybe my tester was just impatient. Yeah, that's weird. Do I have any
My
resonance?
examiner looked like a from Back to the Future, or right? Yeah,
Your examiner looks
it
like
looks strange.
uh. Let me just make one up on the spot. Let's see. Okay.
Can you get me more sauce? I know, but I want the tater tots.
Okay. Let's try drawing the resonance structures for.
The chiropractor.
Oh, hello.
Look at those hands. All right.
Say hi.
Hello.
Come over.
Hey.
Don't be weird. If you have any questions,
Yes.
Uh-huh.
I can ask.
Let's go.
Hey.
Good
Yeah.
luck.
Future
He says good luck.
chiropractor
Available
in
for questions if you
training.
need them.
Yes.
Yeah.
He says chiropractor in training. Okay. Um. Okay, so the carbon on the left with the negative charge has um a lone pair of electrons, right?
Right. It has one lone pair of electrons, and they might not give you the lone pair explicitly, but you have to assume it's there based on the charge it has and what kind of atom it is. So because this is carbon with a negative charge, it will have one lone pair of electrons, not two or not three.
Okay. So then that could make could it make another double bond?
Right. Make a double bond right there. Uh-huh.
Either direction, right?
Oh, so here's another important thing. Resonance only happens in a network of adjacent, so back to back to back, p orbitals, empty p orbitals.
Oh, and the other one is SP because the SP3 is a roadblock, right?
Yeah, this is an sp3 roadblock. Blocks
Okay, because I
resonance.
was like, okay, because the one up above has a double bond, so it's well, it's SP2.
Right, sp2. This is sp2.
Okay.
Right,
Because I
and
was
if you
like,
try to make a
I
double
was
bond
like,
here,
can you take away the hydrogens? And I was like, no, you can't do that.
no, yeah. A hydrogen cannot be taken away. Yeah, right. Because once we make a double bond there, like there's nothing to move anymore. Like no double bond to move. There's no void here, no positive charge. So that's not good. Not good.
Okay, so just up.
Yeah, just up.
Okay.
Uh-huh. And then where do you want to move the double bond to make sure you include the important major resonance structures? Like, do you want to make it go here? Do you want to make it go here and then here? Or how do you want to draw the
I guess we could make it go onto that carbon and move the negative charge over there, right?
negative charge on this carbon right here?
Mm-hmm.
Yeah, that's right. That's right. We don't want to skip all of this just to make sure that we get all of the points. But in future reactions and chapters, you learn when you draw the mechanism, you can skip all the way to this negative charge on nitrogen right there just to save time. But because you're learning resonance for the first time, they want to test you if you know like the in-between resonance structures before you get to that point.
Okay. Yeah, we just barely started mechanisms today.
Oh, for SN2, E2, SN1, E1.
Didn't even get to that. Literally
Oh my
just
God.
mentioned the word and then and started talking about like, basically addition or, like the different types
Yeah.
of like easy reactions from like Gen Chem.
Yeah.
Only they renamed them like rearrangement. I'm like, okay, so double substitution. Cool.
Yeah. Right. Addition, emission, all those things. Oh my
Mhm.
God.
And then from there, we can move it. We can make a double bond to the next carbon.
Right. Between this carbon and that carbon.
Yeah.
Right. So do we want to pop this double bond onto the nitrogen, or do we want to make a double bond right here between this carbon and this carbon?
We can't double bond it to the other carbon because it's sp3.
Yeah.
So we want to
that's
put
right.
it on the nitrogen.
Yeah.
Aside from the fact that nitrogen likes to have a lone pair in general.
Yeah, that's right. Nice. So what charge would the nitrogen have now? Right.
With the lone pair?
Yeah.
Positive.
So, how many lone pairs of electrons does this nitrogen have right here in the original molecule?
Oh,
one lone
so
pair.
it'll have two lone pairs.
It will have two lone pairs.
So it'll have a negative charge. I was like, that doesn't make sense because we need a negative charge.
Right,
Okay.
to conserve the charges in all the resonance structures. That's right. That's right.
And none of the screen.
Right. Now, which one of these would be the major resonance structure?
I told that everybody was not done it.
I went upstairs and figured the upstairs already. Did you change it?
First, look at the most important role. Does every atom have the oxide role? And then if all resonance structures does have the oxide role, then you look at the next factors.
Well, isn't one of them like not gonna have the octet rule because we have to move it around? Like
all of them will have an octet role because every single atom will have like 8 electrons, right? The example where everything does not have an octet role is most likely with positive charges, because they're not positive charges means like we're missing electrons.
Oh, okay, right.
If you have negative charges, then you will most likely have an octet role. There's like an excess amount of what.
Okay, yeah, because the negative charge is there, so that means there's only one hydrogen.
Yeah, only one hydrogen.
Okay.
Right. 2, 4, 6, 8. Every single atom in every resonance structure fulfills the octet role. So that factor does not matter anymore.
Right? Wait, but doesn't... Okay, I was like looking at the charge because I was like, I mean, that's still technically 8 electrons on the nitrogen, so I guess that's fine.
Right.
Okay, so then we want to we want the
minimal
next is
charges.
The minimal charges, which all of them already are.
Right. And all of them have the equal charge, so that doesn't matter anymore. Then the next one.
So then we just want it on the most electronegative atom, so the nitrogen.
Yeah, right. That's the thought process on this determining major and minor resonance structures.
Okay.
Right. Okay. That's good.
I don't even think he really talked about which ones were major and minor.
Oh, really? He doesn't ask about that? Dang.
I don't think so.
Because that's a pretty common question for UC Davis, like OChem classes.
I asked him about the like naphthalene and the
oh yeah
resonance, and he's like, yeah, it technically is the same, but basically we're just looking at how it looks like flat on paper. So I was right, there were 4.
It
wasn't the 3 that Google said, and it wasn't just the 2 because you could flip both of the 2 over and then you have 4.
Right.
So apparently there's 4, and then for naphthalene you just like rotate it in one big circle with the bonds.
Yeah, I know. One by one, like one ring at a time.
Yeah, you just. It's like, okay, cool, whatever.
Right. Do you want to do a Kahoot on one of the concepts you already went over in class? Just of practice.
Oh. Okay.
Like let's say, have you went over newman projections?
Yeah.
Okay.
The one thing that I was struggling with, so my quizzes. He marked me off. Sorry, my dog is barking. On like my energy projections, and I do need to ask him probably better than asking you. But did I send you?
Yeah.
Did I send you the pictures of both of my quizzes?
No, you did not. But you can send it to me now, and then we can go over it now.
Okay.
Yeah. Or you can post it to your Google Drive folder in the class resources, and then I could import it from there.
Oh my gosh, you're so smart. Yeah, that's probably better. I'm so bad about the uploading. I'm like, well, I gotta do it as a PDF, so I need to do it from my laptop.
Yeah, you can just import it from your phone or iPad directly from there.
Okay.
Or
yeah, no, for the pictures it'll go from my phone.
Yeah.
And you can leave me some more. Could you bring me my phone? It's charging.
In the box.
Okay. I will actually I guess I could do it from my iPad. I guess I'll put it in the practice problems one. Take photos. Never mind, I'm okay, Dad. Okay, there's one. Thanks. Okay. Those should be going. Oh, pending uploads have been completed. Okay, good. Opening this
there it
folder
is.
and seeing my cheat sheet from statistics is like giving me anxiety. It was horrible. Look at this.
Oh my god, for statistics? What the heck?
Yeah.
Um,
Really listen to that.
Like he's a high
Those-
schooler watching it.
take a lot of time, like making
Uh-huh.
comprehensive
It took me
study
like
guide.
2 hours. Yeah.
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 My god. But that is a good way to study though, like making it, like the process of making it.
Yeah. So I know for the first one, I needed my other p orbital on the first problem to be horizontal because I guess they can't attach like that, even though he literally never told us that, but that's fine. Yeah, I think I'm feeling awkwardly confident about the exam right now, and I'm really not sure that that's a good thing. Or sorry, the second one.
Oh, the second one, sorry.
The second one, I
that's good.
connected them. Yeah, no, that
Yeah.
was my bad. I thought it was the first question.
Yeah, no problem, no problem. If you did the work in practice, then you should trust yourself, don't, yeah. Trust your gut.
I know. I also need to like grade the homework. I think that's contributing to my ego right now. It's the fact that I'm like, oh yeah, I totally got like most of them right.
Yeah. Right. Okay. So, let's see.
So I asked him to in class, I was like, if it's a CH2 and CH3 eclipse, like, should we just assume that that's like also 11? And he's like, yes, even though technically I'm sure it would be a little bit less than 11, but he's like, you can draw it qualitatively. And I'm like, okay.
Oh, qualitatively.
But this one's
like,
not. These are all CH3, yeah.
Yeah, there's no bulky group here. Like, all of, like, the front carbon, let's say this is our eyeball right here for the Newman projection with the eyelashes. Our vision is going to be like this purple dot. Oh, wait, what the heck? Oh, yeah.
Wait, it's like a little bit laggy.
Oh, yeah. Let me go connect with my hotspot really quick. Sometimes that happens.
That's crazy. Your hotspot's better than your home Wi-Fi.
I know. I think I'm just at a weird spot in my house that it doesn't connect to the Wi-Fi that well.
I can't talk. The Wi-Fi doesn't even reach to my room, so I'll just like drop calls when I'm back there. I'm like, oh okay. Oh no, now it's very laggy.
Oh, okay. We're back. It should be much better now.
There we go.
Okay, so this is gonna be the front.
My internet connection's unstable. Hello.
Right here, which is gonna be represented by the dot carbon, is gonna be right here. This bond right here between the front carbon and back carbon, we cannot see that bond.
Right.
Hydrogen. So if we look at the first carbon here, that's gonna be represented by a dot. So that's gonna be connected to two methyl groups and a hydrogen like that. Right? The back carbon is going to be represented by a circle. Like this circle here is representing the back carbon right there. Right?
Mhm.
There it is a bond between the front carbon and back carbon right there, which is going to be between that dot and the circle right there. But we can't see it because we're directly looking at the first carbon, which is blocking our vision of the bond between these here. But because these groups are sticking out of the back carbon, we do see the groups sticking out of the back carbon here, right? Which is attached to a methyl group, and a hydrogen. Notice in the way that I drew it like equally distant from each other. Like all the groups are like have the same angle. It's gonna be like a 60-degree angle. Do you know what conformation is it? Like, is it gonna be staggered or
Gauche. Staggered.
Staggered, right, staggered. And then in staggered, right, there are two names that you have to be familiar with. You said one of them, gauche, and do you know the other name that you have to be familiar with?
Anti?
Yeah, gauche and anti. And for these ones here, you have to find it's relative to the bulkiest.
It's kind of like cis and trans, right?
Yeah, it's kind of like that. Cis and, or it's same side, opposite side. It's not really the same concept because cis is talking about the same side, trans is talking about the opposite side. Gauche and anti is more talking about steric hindrance, like the distance between the bulkiest groups. If the distance between the bulkiest groups are 180 degrees from each other or anti each other, they're anti. if the bulkiest groups are like right near each other, but it's still staggered, then that's a staggered. There's no like spatial rearrangement, like same side or opposite side. It's just the distance between
Yeah.
them.
But it's like similar.
Yeah, similar to that. Right.
For the building codes.
So in this example right here, we could technically say this is both kind of anti and gauche, because if we look at the first carbon here, our bulkiest group like are these methyl groups here. And the back carbon, our bulkiest group are those methyl groups here. The way I drew it here, notice how the methyl of the methyl of the first carbon here is anti to this methyl of the back carbon. That's the anti part of it.
Right. And then the other ones as well, because they're both equal.
Right. And then this is the gauche portion of it.
Okay.
Right?
Okay.
So in this example here, we can't really see anti and gauche, but if like let's say we had this ethyl and then this isopropyl, then we could say that if it's like this, what would this be here? If the ethyl group is on top on the first carbon and the isopropyl is on top, anti, right. That's more clear to see the anti. In this specific structure here, we can't really like. Yeah, it's kind of hard to distinguish between anti and gauche here for this one because there is basically both. Right. And what is the stability of anti-conformation? Is it stable or unstable?
It's the most stable, right?
It's the most stable, right? And then what do you know about the relationship between stability and energy? Are they directly proportional? Like the more stable something is, does it have more energy or does it have less energy? The more stable something is.
Less energy, more
Less
stable.
energy. Right. So they're inversely related. That means the anti, since it's the most stable, it will have the least energy. Right? So it should have the least energy in this energy chart right here.
Yes.
Right?
Yeah,
Now,
it's the least energy.
least energy. Right. And then we could just go off of your thing here because it's actually pretty good, like the methyl.
Oh, thanks. I had no idea what I was doing.
Wait, is there OChem class like all online or?
No, I go in person every day. I drive from Orange County to LA for 4 days a week.
Oh my god!
And then I have lab for sometimes 5 hours after class.
5 hours. Oh my god!
Condensed because it's like from 2 to 9:45 technically is the time.
Right. Dang, that's crazy.
It's amazing. The gas mileage is just so good.
Oh shoot! Yeah.
Fill up like every other day.
So to convert a Newman projection to another Newman projection, we rotate 60 degrees, right? So let's say we rotate the 60 degrees. In this case, you did
and you leave the front, right? He told us to leave the front.
Yeah, keep the groups in the front the same, stationary.
Okay.
Right. So if we look at this front carbon here, like this methyl hydrogen, they have to stay the same.
Yep.
Right. The only groups that are moving are the back carbons, which are this hydrogen. This like this
like
is moving around. Yeah. This hydrogen, methyl, and methyl on the back carbon is the only groups that are moving. Right? You rotated it this way right here because. Oh wait, no, the other way.
Yes.
Yeah.
I was like, I wanted to like skip, and I was like, no, it's going here, and then it's gonna go there.
right. Like here.
I had to look at the example.
Yeah. Oh, and what would this confirmation be like now? Is it staggered or what is it now?
Eclipsed.
Eclipsed, right? Did he talk about torsional strain?
Yes.
So this eclipse here does have a lot of torsional strain, which means like the angle between the groups, like it's basically 0 degrees because they're on top of each other, right? Eclipsing each other. This introduces a lot of torsional strain. Oh, what the heck?
Yeah, and then depending on what the groups are, it could be torsional and steric, right?
Right.
The methyl overlap is both.
Yeah, right. If the bulkiest group overlap, then that's the steric hindrance thing. Right.
What's the technical difference between the two?
The technical difference is that steric hindrance refers to the bulky groups bumping into each other, touching each other.
Okay.
Right?
So it's only talking about like the bigger ones.
Yeah, the bigger ones. Right.
Okay.
Torsional strain is the distance between the groups, and the groups, they don't have to be big. They can be small, and they don't have to touch each other. If they don't touch each other, that's not steric hindrance. But if the distance or like the angle between the groups of the bond is like very close to each other, then that's torsional strain. Because what is the preferred bond angle of a tetrahedral sp3 atom?
109.5.
109.5, right? That's the preferred angle. If they're like smaller than that, by rotating the bonds and they go away from that preferred angle, that's torsional strain. Right?
Yeah, he was talking about that. He was modeling. He has like a big model kit. And
Right,
so when
right.
we were doing like all the different like rings, he was talking about how like this one pops out of plane and blah, 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 blah.
Yeah. Like he was showing you with the model kit, right?
Mm-hmm. A big one.
Yeah. I'm looking for mine right now. I don't know where it is. It's somewhere in my desk, but my mom put it somewhere. It's like, where is it?
And you're like, oh, I appreciate it, but where'd it go?
I know. Dang. What the heck? I'll look for it later. It's okay.
I bought mine for Chem 2C.
Yeah, I can't do
And it was helpful for like, it was really helpful for like chirality because I was like, how can these not superimpose? And then I was looking at them and I'm like, they can't superimpose.
Wait. Like, it doesn't matter if you rotate it, flip it, they can't like superimpose, right?
Yeah. She was like, you're going to need a pro chem. And turns out I do.
Yeah.
So that's why there's torsional strain when the hydrogen's eclipsed.
Right.
But only torsional and steric for the bulky groups.
Yeah. In this case, because this is a weird case with no like bulky group for both carbons, this case is actually having torsional strain on this side, and this is torsional strain and steric regions because the methyl and methyl are touching each other like that. The bulky groups are touching each other. So it's not that clear to see in this example because this example has like the same bulky group on both like carbons, like two of them. Right.
But I mean, they're both still the bulkiest for each like carbon.
Right. So yeah, I think you got it. What was your question about this problem?
Oh, okay. Let me see what he commented on the canvas.
Yeah.
I mean,
what
like, if it looks good to you, because he decided to give me an 8 out of 10. So.
Oh my god.
I know. Like that's harsh, right?
Wait, what is this stuff? Like, I've never seen.
Oh, that was my math. Oh, he gives us values.
Wait, what? I've never seen values related to this stuff before.
Yeah. So like the methyl overlap is 11.
What?
And the methyl hydrogen is 6. So that's and then that's how you plot it up above.
Oh, and that's how you determine energy?
That's why they're labeled there.
This is my first time seeing this concept. I have never seen this concept before.
You know it's bad when he says he's never seen this concept before.
Yeah.
Isn't that crazy? Davis is so different. Yeah. It's okay. Yeah. I mean, it makes sense. Okay, wait. That's JK. He gave me an 8.5 on this one because this is the second one. Okay. He circled. He said 2x, 3x, 8s. No idea what that means, my guy. But he circled the way I drew my stuff.
Wait a minute. Okay, let me just look at this one by one specifically. So rotate that way, rotate this way, gouge. This rotating again makes it into eclipsed. Yes, eclipsed, and rotate again makes it into gouge. And then rotating again makes it eclipsed, and then rotating it again makes it gouge. Yeah,
I'm not sure because like on some of his like, and I don't think it matters. On some of the examples, it starts the bottom axis at 0 degrees on the left and then goes to 360. But the second example was like this. And so I was like, okay, I'll just do it like this because this was the one I was like modeling mine after.
Yeah.
But it doesn't matter where you start as long as you rotate 60 degrees each time, right? You can label it however you want.
Right, it doesn't matter. And then as long as
it's a freaking circle.
Correctly as well. I know, yeah.
I'm sorry, like how many different ways can you draw a circle?
Yeah. I would ask him about like what those means, like circles means, like, and then can you get back to me on like what he like has on that, like
oh yeah, of course. Okay, let me see what he said for the first one because I know, like I said, that one was like the pi orbitals. The second one needed to be horizontal.
Yeah.
Oh no, okay, this is not an S. This is a 5. So he said I got 100% on the first one. Oh, and then I guess he just took off 2 points arbitrarily. 2. See, in my mind, that should only be 1 point.
Yeah, I know.
It should have been a 9 out of 10, my guy.
Like, for this thing, right? For this?
Yeah. And he never said, "Oh, you can't connect them like that." in class. Like, I mean, I guess it makes sense. Like, you know, there's like too many in the orbital, but like, okay, like it looks prettier that way.
Yeah, I know. Like this like direct overlap or like in between.
It looks so nice. Like, who wants to draw horizontal pi orbitals? Nobody. Nobody wants to draw horizontal pi orbitals.
I know. In a 2D paper, you can see in a model, like a 3D model, but in a 2D paper, it's like so crowded.
Do you just D? I can't imagine drawing a D orbital.
The orbital? Oh no, I don't even know what that is. Like what it looks like.
It's the donut.
Oh my god.
Remember?
Yeah, I remember projecting. That was like years ago.
Yeah, that's crazy. No, I know. I've honestly so far been enjoying OChem more than Gen Chem. I'm like, it's only carbon. Like, it's so much easier when it's only carbon stuff.
I know. But like once you get to the real meat of OChem, like the SN2, E2, SN1, E1 stuff, that's when it gets like a little bit overwhelming. It could be a little bit overwhelming.
Yeah, I'm sure it will. Because like right now, I'm like, I don't know. I'm like, I don't even have to draw chairs on this exam because we went over that on Monday.
Oh yeah. That's
and
good.
like he tests on the week prior, so except for the last week.
Will acids and Newman projections be on this exam?
Yeah, so it's chapters 1 through 3, which like broadly is structure and bonding, polar covalent bonds, acids and bases, and then organic compounds, alkanes, and their stereochemistry.
I see. What do you need help with the most? Newman projections, acids and bases, or stereochemistry?
Probably like the acids and bases. I have no idea why that trips me up so much, but I think I still need to go over the like rest of the ones.
Yeah,
but I mean, we could do more of them because I haven't like looked at them again since you explained them yesterday.
Right.
And that was great.
Yeah.
But and then also I'm just like, I know how to do resonance and I know the isomers. Is that gonna be on here?
Enantiomers, diastereomers,
I feel like
isomers, mesomolecules.
This one says, yeah, we just covered, oh my gosh, and then you were talking about meso yesterday, and then today we talked about meso.
Oh my god.
It's like, wow. Okay.
What a coincidence, huh?
No, I mean, I'm just tracking at the same pace, just twice as fast.
Yeah.
I guess probably a little bit because it says for chapter 3 alkanes and their stereochemistry, but just not for cycloalkanes.
Not for cycloalkanes. Alkanes, yeah. Okay.
Yeah, because that's chapter 4 and it'll be on the next exam. So yes, I think honestly, let me just look at my homework. What won the freaking because I got like 5 out of 8 of the isomers drawn, and I was like, there's got to be a better method to do this. It was homework 3 actually. It was like if you want to look at the question, it was like the questions were 28, 30, and 34
for chapter 3.
Yeah.
Okay, yeah.
Because it was the line bond structures, which I'm like decent with. But I was like, yeah, and then oh my gosh, she had us do another like Newman projection energy diagram on question number 44, and I was like, what?
I know the energy diagram. Okay, what was the question?
28 was the first one.
28. Okay. Oh, the 9 isomers of C7H16. So that's asking for the constitution isomers. That question is like barely tested because of like it's very like it takes a lot of time. It's time consuming, very time consuming to draw out every single.
Okay, see, so on first try, I correctly drew 8 of them.
Did you have rings in there as well? Oh, maybe try.
There weren't any rings on the at least what I googled. Yeah.
Oh, okay.
Because it's alkanes is the chapter, not cycloalkanes.
Not cycloalkanes, yeah. 3, 4, 5, 6.
But I'm pretty sure I may have done that, and then I was like, nah. Yeah, so I started with that one. That's the first one.
9.
Then he's always says you reduce it by 1, see how many places you can put it, and then reduce it by 2, see how many places you can put them, and then until you can't do anymore.
2, 3, 5, 6,
yeah, that was the next one that I did.
And
then I moved it to the next carbon. Yeah, exactly. And then I did that one, but that's the same as the first one.
Yeah. Right.
And then I did the end, but that's also the same as the second one.
yeah. This is a good one. So we gotta.
So then you reduce it by 2, and see where you can put the 2 of them. Yeah.
1, 2, 3, 4, 5.
I did like the two little triangle looking ones. So, oh yeah, that see, I didn't do any of the ones that look like that where you put two on the same one.
Two
That
on the
was
same
my
carbon?
problem. Yeah, I was like, didn't feel
Uh,
right to me apparently. I'm not sure.
yeah. Okay. You could do this as well.
Actually, I did. I just put it straight up and down for some reason.
Oh, say up and down? Oh,
I drew like a line. I put one on top and one on bottom.
like this?
Yes.
That's acceptable as well, but I like looking at it like this better.
That looks a lot better, yes. So I did them correctly in my mind. I still marked this correct. But I was like, something doesn't look right. Like,
let's see. 1, 2, 3, 4, 5, 6. Okay, three more.
yeah. You can do more of the like single leggy. You already drew that one.
Single
think.
leg. We did that side, which is the same thing as that side. This side is that side.
No, the like I put two on like the up mountains. Like I put two trees on the mountain. I put a tree on each mountain.
Wait. Which mountain are you talking about?
So like the first two humps, like the up carbons, I put one on each of those. So if you go back to the first one and you just take two off the end, and then I put two on the first two, like top pieces.
1, 2, 3.
And then one more down. Yeah, and then one up from each of those. No. The second carbon, if you're numbering from the left, the second carbon and the fourth carbon.
Oh, like
yeah.
Like this.
No, but just one on
Just
each, and then one on the second one.
One on the second, like this. Oh.
Yeah.
Oh.
Yeah.
And this is the mountain right here.
Yeah, the mountain.
I see. Yeah. Try naming this in nomenclature. Try naming that structure in nomenclature.
Well, it doesn't matter what direction you start from. So 1, 2 dimethyl 1, 2, 3, 4 pentane.
So this is pentane, right? But the methyl groups are on carbons 2 and 4.
Oh, did I say what? Yeah, that's I meant 2 and 4.
2, 4, dimethyl pentane.
Yes.
Or you could say the lines on the two mountains.
Yes, the lines on the two. That's exactly what I'm gonna write on my test.
Right.
My friend in one of her OChem classes, she was like, I honestly don't know the answer to this anymore, so I'm giving up now. And she wrote that on her test.
Oh my god.
Partial credit? Going through it. I don't even remember how it was graded, but I was like, oh goodness. The poor TA when they see that.
And what was the 8th structure that you drew out?
Okay. Okay, so I put 2 on the second carbon, I put 2 on the third carbon, and then I put 1 on the second and 1 on the third carbon. And then yeah, you've got
oh, this is way too many.
So hard, like matching them. Yeah, sorry, not that. I was not being clear with what I was saying. Did you reduce it? No, you didn't.
Oh, like this? 1, 2, 3, 4, 5, 6 of it.
Yes, I did that. Yep. Oh my gosh, I just had deja vu right now. Yes, that.
1, 2, 3, 4, 5, 6, 7, 8. We were missing one more.
Yeah, yeah, I know what it is. I'll see if you get it.
Wait, no, that's the same thing as this one.
Yeah, it is.
Okay, let's see.
It's the hardest.
The hardest one?
In my opinion, yeah.
Okay,
think of. I can give you a hint. It might sound a little crass. It kind of looks like a swastika.
Oh shoot! Let's see.
Yeah, but just 3 legs. But just 3.
Legs.
Yeah, so erase one of
your. That's
erase 2 of them. Yeah, and then just leave 1. Yep.
Oh wait, what the heck?
Music just coming on at the same time as you finishing it.
That was a celebration music, like perfect timing when we just finished it.
That was hilarious. Yeah, so that was like I only missed 1, but I was like, ugh.
Yeah, this one here, huh?
Yeah.
Yeah, so all of these here, they are constitutional isomers, which means that they have the same chemical formula,
But different orders.
Yeah, different order or different connectivity.
Yeah, different bonding order.
Right. And then when you learn about enantiomers, diastereomers, mesomolecules, and stuff like that, that's going to be stereoisomers. Constitution isomers is a regioisomer.
Oh, he didn't say that word.
Regioisomer, right? A way to remember that is region, right? The regions of the group are different. Stereoisomers, think of a spatial.
Yeah.
Rearrangement. Like enantiomers, diastereomers, those are spatial. Like they have the same connectivity, but the way they're arranged spatially is different. Stereo isomers.
I hate the way that he goes about identifying a chiral center. He's like, so you look, if it has 4 different groups, but then, say it could have 2 CH2s, but then if you go 1 bond higher from each of the CH2s and it's different, it's still considered chiral. And I'm like, my guy, that's like 1 level too far. I'm like, how far around the molecule am I going right now?
Right. Did you see that question from yesterday? Like that one person asked about why this was not a chiral center?
Yeah, I heard her really struggling with it, and I was doing my homework.
Right.
Why it's not a chiral center?
Yeah, why this is not
because it's the same all the way around. Like if you keep going, it'll be CH2, 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 CH2.
Yeah, right. What about?
But if there was like an oxygen on one of the bottom ones, yeah, it would be chiral.
Yeah, that's a good cover. What about this?
Not chiral.
Not chiral, because this is equally listed to the methyl as this right there. That's what we went over. And then he talked about that in class today.
I hate how you can like split it in half. Like I'm like,
oh yeah.
Why is that considered a plane of symmetry when there's only 1 oxygen there?
I know.
Or whatever, a carbon in this case. Yeah, he talked about that today. Literally.
Oh my god!
Like everything's just going about today. We talked about
Dang, that's actually so crazy.
And she's on week 8.
Yeah.
I'm on week 2.
Week 5.
5.
Yeah, out of the 6.
I was like, week 8's her final. Hold on a second.
Oh my god! And you're in week 2, and you're talking about this stuff already. Like you're moving it so fast.
And apparently, we still have room to fit like values into the electro, Newman projections.
Stuff. Yeah.
Horrible.
Oh my god.
Yeah, and then the next isomer question, I only drew 3 of them correctly.
Which one is it?
30.
30. Oh, okay. 7, C4, H10. Oh, what did you have so far on this one? You could send me a picture or you could describe it.
I had like oxygen with 2 electron pairs in the middle and like 2 carbons on either side. Yeah. And then I had it moved, like oxygen moved to the right or the left. It would be the same,
Right.
Yeah, like that. And then I did, I had it at the end and then 1 extra carbon sticking off. Like a fork at the end. Yeah.
Right.
So an extra, that was all I got correctly. And then I tried throwing like double bonds around, but then I in fact realized that was not at all what the answer was.
It reduces the hydrogen atoms if you put the bonds in there, double bonds or triple bonds in there.
Oh.
Yeah, it reduces it because if you put a double bond right here, now this carbon and this carbon only has 1 hydrogen.
See, this is why like a freaking like resonance and isomers like merge together in my brain.
I know. Let's see. I'll try this here. 1, 2, 3.
Yeah, so I moved a bunch of double bonds around it. And I was like, that's not right.
9.
Once I go
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, that's one that works.
Yep, that's one of them.
This is another one. 3, 6,
yep.
10. 1, 2, 3, 4, 5. 2 more. We could say.
I had 7 total.
7 total. Okay, 7.
With the correct answers in there.
Let's see it. Let's put an alcohol there, and let's put this here and that there. 3, 6, 8, 9, 10. 1, 2, 3, 4, 5, 6. One more. There's one more. Let's see.
It's real weird. It's like the last one you drew, but the oxygen is moved into the center of another carbon.
Um,
Yeah, yeah.
3, 6,
That's all of
9,
them.
10. Oh my god, that was a weird one.
Look at you go.
Oh my god. Yeah, like this type of question here is barely tested at UC Davis classes because it's too time consuming and like yeah, there's a lot of like possible ones.
We have 2 hours to take our 12 to 15 question midterm.
Oh, 2 hours?
But
It's
some
one
of
of
them might be like multiple parts, he said, and I mean
yeah.
that definitely means that they will in fact be multiple parts for sure.
Right. And I think this will show up probably because there's like 2 practice problems that he assigned you related to like
3. There's
isomers.
another one.
Yeah. Dang.
Yeah. I did
Have you
it.
tried?
I did that one good though, I think.
That's good. Yeah. Have you tried the practice exam he posted, or did he post any practice?
He doesn't do that.
Oh dang.
No, but he did highly recommend doing the homework at the beginning of the beginning of this class. Oh
Yeah,
crap, I
yeah.
need to plug in my laptop.
Uh-huh.
So I'm assuming it's gonna be kind of similar to the homeworks.
Right.
And I mean their difficulty level didn't get like crazy out of whack. I just need to like correct them now so that I
Yeah.
can like, keep my ego in check apparently.
Yeah, and you know the notes that I posted yesterday on the school community. If you
Yeah,
access
I need to get better at like navigating that. Can you
Oh,
put this
yeah.
email
right.
over there? Please. Can you take it? Thanks.
You can see practice problems related to stereoisomers and chair conformers on those notes right there. The notes of the last night's office hours.
Ooh,
So
look,
that
okay,
could
I have
be
it on my iPad. Okay.
also determining if they're constitutional isomers, enantiomers, diisomers, or mucin molecules as well.
Okay, good. That'll be helpful for like the next one.
Yeah.
Oh my God. I always forget what email I use for things. I just did my UC Davis email, but instead of putting at UC Davis, I put at Gmail.
At gmail.com.
Yeah. Oopsies. Save password. Okay, there we go. I got logged in. Okay, so then it's under community.
Classroom. Yeah, summer session 1,
Okay.
2024.
Okay.
And then week 5, and then the notes. The Monday, July 22nd, 2024 notes.
Okay,
the
yes, I
PDF
see those.
file.
Perfect.
You just go
Yes.
down. Then there should be practice problems and notes on the stereochemistry stuff, and the chirality as well, like chiral centers and.
Wait, it only posted the first page, I think.
Oh, can I see?
Unless I'm like stupid.
Oh, click on the.
Okay, that's not helpful. Hang on, it just closed out. You're like, click on the PDF. Is it okay? There we go. Loaded.
Scroll down.
Because when I was scrolling, it looks
stops
like it's
there.
only the first page. Apparently, I mean, it doesn't swipe.
Wait, what? It should slide. Wait. Hold on. Can you try? Let's see. What's going on here?
Oh my gosh, I love the puppy. It's so cute. Okay, so it's totally there for you. So what's up with me?
Yeah, like I see it here. Yeah.
Do I need to hit download maybe? And then it'll like
Yeah,
show
maybe.
me the whole file.
Yeah.
Okay. Yes, then it shows you all the pages. Just
Okay,
I guess
that's
it's
good,
like
that's
a
good.
preview.
Yeah.
Okay. Chirality, optical activity, assigning artists. Oh, 37 pages. Wow.
Yeah.
Okay, yes, I see that. Chair flips. Oh.
Chair flips. Is that included in the exam as well? Like there's an exam?
No, because we talked about chairs on Monday.
Oh, okay.
Thank goodness. Yeah, it's just alkanes. So
Just
cyclo
alkanes.
isn't even a thing.
Okay. No chairs yet. Yeah, that's good.
No chairs, yeah.
Axial equatorial.
Nope. Even though I do get that.
Yeah.
I think so.
Uh-huh.
Yeah, I'm gonna have to like download. I don't know. It just made sense. I feel like stupid saying that. I was like, yeah, axial equatorial. I'm like the only one in class saying the answer. I'm like, and then I get like one wrong, and I'm like, oh, oops.
You're natural at OChem.
I just not Gen Chem.
Yeah, not Gen Chem. Same.
Gen Chem and me do not get along. Watch out for Gen Chem, Ryan. It'll get you, but it gets everybody.
Yeah. I prefer OChem over Gen Chem for sure.
Yeah, my dad's like, it'll get worse. I'm like, okay, cool. So I just need to go onto some sketch website and find the answer key to my homework.
Oh, the homework, yeah, I see.
Right. Okay, I'll be fine.
Yeah.
Okay. Well, it's 10, so I'll let you go.
And I'll see you maybe tomorrow if you decide to come and we can prepare more for your midterm on Thursday. Yeah.
Definitely. Yeah, because he's like, we were trying to convince him to like, tomorrow's supposed to be the longest lab because we have lab every day, except for Thursday when we have exams. So tomorrow's supposed to be the longest lab. So we're like, can we like do that on Monday? And he's like, yeah, I'll like give you guys the option. So I'm like, I don't need to be here until like 10 p.m. doing my lab when I got an exam the next day.
Yeah, I know. Yeah. That's good.
And he's like, well, you should be studying more than just the day before. I'm like, yeah, but still.
Yeah, I know. So 2 weeks too.
Doesn't matter.
Oh my god, yeah.
I know. I'm like, So yes, I will definitely see you tomorrow.
Okay. Yeah.
Okay. Good night. Good luck. Do you have another quiz or anything?
This Friday. So I got time, but I gotta start studying for that and
start now. Yeah.
Start now. Yeah.
Okay. Good night.
Good night. See ya.
Bye.
Bye.
Hello.
Hey,
Yep.
hey. we were talking about you at the beginning, like about your driver's test, how you're gonna take OChem later in university.
Maybe.
Yeah.
Mm.
And then she said good luck to your driver's test too.
Oh yeah.
Yeah.
I wasn't there probably. I think I was taking a shower or something.
Oh, I see. Yeah. It's good. So like right after she went on, you just went to take a shower.
Yeah.
I see. That's good.
Mm-hmm. Wait, so like you're doing chiropractor school, so like when does that end?
Chiropractic school will end in 3 years for me because I'm in the accelerator program, so I'll be done in 2027, summer 2027.
Oh, okay.
Okay.
In 2027, let's see, I'm 16, so that'd be 19 years. That'd be 19 in 2027.
19 years? Oh, 19 years old. Yeah.
Yeah.
I thought you said like 19 years of school or something like that.
Yeah.
So that time you'll be like your sophomore year of university?
Maybe.
Yeah. That's good. And then that time I'll be 24. Dang.
That's crazy, actually.
And you'll be pre-dental, pursuing dental school applications, DAT, dental admissions test, extracurriculars, working in the dental field.
Yeah, just because I basically my family, I have like two siblings. Like my brother, he's not going to go to college, and then my sister, she's going to Sac State, but she's paying for all the materials and the stuff herself, and like has her own car, so she's paying for that too.
Oh
And
my
so
god.
basically, both my parents had like money for like all three of us are actually using all of that money to splurge on me.
Oh shoot.
Yeah.
So you're lucky.
I am.
Yeah, that's good.
The thing is that if I ask for money, they'll just give me it. It's like, oh shoot, I can't abuse this power.
Yeah, I know. Like that's a lot of resources that you have available. So you gotta use that like wisely. Can't put it to waste.
Mm-hmm.
Yeah, it's good.
It's also funny is that like over the years, I'm the only one who gets paid for my grades. That's it, just me.
like an A is a certain amount of money you get. B is like certain amount. Like how much
Yeah,
did I
that's
pay
it.
you?
Honors and APs don't count. They're still the same.
Oh, like so they don't weight it. Like they don't give you more for APs and honor classes.
No,
Dang. How much did they pay you for an A per class?
$10.
$10. I see.
And then B is like $5, and then there's nothing else for C.
Uh-huh.
Yeah.
Dang. $10 for each class. So that's like 7 classes. So $67 if you get A's for all classes.
Yep. Honestly, money's not the goal right now. I'm just actually trying to like get all A's just to show that the university I want to go into, like I improved.
Yeah, the upward trend of your grade is actually important because if they see that you can improve, then that's a good sign. Good sign.
hmm I mean, wait, let me look at the classes I signed up for. I wrote them down somewhere. Wait, do you have anything for tomorrow that you have to do?
I have class at 7:30 a.m.
Mm,
Yeah, that's basically it. So just class, chiropractic class.
not bad. Great.
Wait, no, it's okay, it's okay. I like talking, catching up.
Yep.
Cause I wasn't gonna go sleep right away. Like I was just gonna like stay up a little bit longer. So
Mm,
I enjoy this time talking.
That's good. That's good. Let's see. AP Lang, AP Cal. Well, no, AP Lang Pre-Calc, US History Regular, and Biotech. And there are that's like AP Honor, and then there is Pre-Calc, and then let's see, AP Chem, Calc, Micro, and Spanish too. So that's an AP, calculus, and then there's another honors class.
Oh shoot! So there's a lot of APs and honors.
Yeah, even
Good.
though I like dropped like 5 APs, it's still
It's still a lot though. Are you
yeah.
planning to apply to like the pre-dental program for UOP? Like they put you in the dental school automatically after some undergrad over there, or just apply for a bachelor's degree and then apply to dental school later on during your undergrad?
UOP to school like pre-dental, I guess.
Oh, the pre-dental program.
Yeah,
That's
the
good.
program.
Still a lot of time.
Not really. It takes like 5 years. If it was like a normal thing, like the bachelor's, then you just
Mhm.
like it takes 8 years.
Yeah, yeah. That's
Yeah.
3 years. 3 years. Save 3 years.
hmm
Yeah. So the 5 years, is it 2 years undergrad, 2 years dental school? Is it 1 year undergrad, 4 years dental?
I didn't look too far
Uh-huh.
into it. I just know what like where I'm going. Also, I got
Uh-huh.
like UOP merch, so
Oh yeah, yeah. Dang, so you committed already.
yeah.
Dang, that's good. Like do your research on that school, what they look for in an applicant, what they value, and then do activities that are related to those values and write about it in your essays, application essays, and interview too.
hmm
And it'll show that you align with them and you did your research on them.
Yep. Yep.
Yeah,
Hmm.
that's good.
Let's see. Okay, so when did you like? When's the most stressful part, like time in your life? You know?
Oh yeah, the most stressful time in my life was probably when I was a pre med. Like when I wanted to become a doctor, MD or DO, get into medical school. In college, and I was handling studying for the MCAT, tutoring, working as an EMT, taking a full on like workload for his full time student. Um, uh, Trying to balance out my social life at the same time as well. Uh, uh, and that was like the second, third year of college because my first year of college was all COVID, everything was shut down, so I just stayed home. But by the second and third year of college, happened, the in-person classes started opening up again. That's when I tried to get to medical school, like do everything I can to get there, work as an MTA, tutor, and take a lot of classes that are going to help me study for the MCAT. Study for the MCAT. I registered for the MCAT already, but then I switched my third year, so then I'm not as stressed anymore.
Oh, so you didn't take it yet?
Yeah. Or I'm never gonna take it because I'm in chiropractic school now, so I'm not gonna go to medical school.
That's good.
Yeah. I switched.
I can't say that for myself because I was just probably fooling around the whole time. Like, it's not even that serious.
Hey, you're just in high school right now.
Yeah.
Yeah. So like, there's nothing to worry about. Yeah. Well, applying for colleges, I remember that time was pretty stressful as well. Like the application season, like the beginning of senior year or like the end of junior year, like
Mhm.
that season was pretty stressful.
Yep.
Yeah.
Let's see. So, like, how long did it take for you to, like, write, like, your essay? Just to, like,
So
don't procrastinate on it, you know?
yeah, it actually like the outline of it took a day, like from beginning to end took a day when I just like wrote down whatever was on my mind. But it was very bad. It was just a first draft, and then over like weeks and months, I revised it, asked my English teachers to read it over, edit it, and they actually make it way better. Asked my counselors at school to revise my essays and what to input as well. And then it's just a lot of iterations over time that made it better. But the hardest part, in my opinion, is actually like getting down an idea of what you want to write down at the beginning, like getting over that hump, getting over that writer's block, you know. But just
Mhm.
like brainstorm whatever you have on your mind to the document or the application essay, and don't worry about it being good yet. Right? Just get it out there, and then like write as much as you can, and then like go go to sleep or go away from it for a while and go come back to it like the day or 2 days afterwards, and then read over it again, and then get rid of the stuff that you don't want anymore, and then at the points that you thought is really good, try to expand on those points and give more examples, clarify yourself, explain more on those things and how you can build on that for your application essay, and then like make it more structured instead of like bullet points, make it into paragraphs, organize it better over time, and then like go back and forth into it over time, right? But the hardest part is the beginning stage, like when you're trying to like write it out, because I feel like a lot of people try to do it everything perfectly at the first time, and that
Yeah.
makes it very stressful, and like that it makes them procrastinate on the essay, right?
Yep.
But reframe it in a way that you are actually trying to make it as bad as possible, and with as much as possible as well in bullet points, right? And then one of them might stick, like one of the ideas might be really good, and you expand on that, you know. And then like
Mhm.
you get more ideas like as you get more experiences, activities, and stuff like that as well. So make notes on like or journal on your activities. So when you do start your application essays, you could go back to that journal or notes, and then talk about those experiences you did and how you grew from that and what you learned and how it changed you.
Mhm.
So this junior year, yeah, have a journal of experiences that could be useful for your application essay.
All right.
Yeah.
You know what's funny is like when like they like you write something like how have you changed over the years or like leadership or like someone of the was like did you like have an example of that or like
Yeah. For especially for the UCs, personal insight questions, PIQs, there's like 8 possible essays. You only have to write 4 out of the 8, and then you get to choose whatever 4 you want to write. And then one of the questions was like that, like how have you changed? Like how are you a leader or something like that. It's very similar. I don't know about UOP though. I don't know how the questions are for UOP, but I feel like it's gonna be similar. Similar.
mm, did you write like what was your example for like writing that? You know, like, what was your essay about?
Yeah, so I was president of the cooking club at my high school, so I talked about that. I talked about wrestling team, and how I grew from that, the adversity I went through from that, how I was like bullied as a kid, and I started doing martial arts, wrestling. Um, I could actually send you my college essays if you're interested in reading it.
Oh hell yeah. Hell
Yeah,
yeah. I read my dad's college essay. You know what's funny?
Yeah.
My mom only has a GED, and my dad only graduated high school from the age of 16, and then he just like, because like he's just like skipped like four or five grades, and then he just
Wait, he graduated college in 16 at 16?
no, he graduated high school at
Oh,
16.
high school 16. Oh my god.
And then he got his bachelor's there, yeah. But that was
Yeah.
just because he didn't want to live with his brother at the time. So like he just like forced himself to like, oh, and you know what's
Yeah.
funny is like he was 12 years old, but then his like older brother said, nah, he's a second grader. He's like 8 years old or something.
Oh my god. What the heck? Is your dad a first generation student, or is he like, were his parents born here in America, or
Somewhere else. I guess we immigrated. So
oh, like, were your parents born uh at a
Cambodia.
different country? Oh, Cambodia, and then your dad went here and did his or high school here, or
Yeah, no experience, no English, no nothing, just and then boom.
I see,
Yeah,
dang.
we we're very fortunate.
Yeah.
But I think trauma dumping on the essay is probably the best way to like
Yeah.
expose yourself.
Yeah, right. Trauma dumping. That's basically what it is, trauma dumping. Wait, what's your email? You could type it on the Zoom chat and I'll send it to you.
Okay.
Yeah. Wait, that's email.
Email? Okay.
Yeah, email. Okay. Ryan. Oh, were you born in 2008?
How did you know? Yeah. Well,
Oh
I'm
wait, I see the 08
16.
there.
I'm 16, so
Wait,
yeah.
what was that? Sorry.
What?
Oh, June 15th or what?
Okay, so my birthday is 123.
One, two.
Like, I'm not
Oh,
kidding.
January
0,
20.
1, 2, 3.
Oh my God, January 23.
Yeah. Like
Yeah,
no one like you cannot forget that. It's 1, 2, 3.
yeah, 1, 2, 3, 1, 2, 3. January 23rd. Is that Aquarius?
Huh?
The zodiac sign Aquarius? I'm
Uh,
not sure.
Pisces.
Oh, Pisces. Okay, I just sent you the Google Doc or the document of it to your email.
Okay, thank you.
Uh-huh. Yeah, I was born in November 16th, 2002. So Scorpio.
Scorpio. I don't know a lot about zodiac signs, but I
Zodiac
just
signs.
yeah.
Yeah. But you know you're Pisces, so that's good. That's good.
Yeah, I don't know what that means though.
Yeah. Yeah, me too. I don't know about the other zodiac signs. I just know about mine.
hmm
Were you able to access it?
Wait, let me try.
Okay.
Hmm. Let's see, junk. Okay, found it. Okay. Open. All right. Yep. I got it. Well, I got
Nice.
yeah, prompts. Oh,
Yeah.
yeah. Yeah. Got 8 prompts, but so you yeah.
We get to choose 4 of them, 4 of the 8 prompts to answer.
I think I'm gonna read this tomorrow in the morning.
That's good. Yeah. I'll probably see you tomorrow night in office hours.
Yeah, I will.
Yeah. Okay. I'll see you tomorrow night, Ryan. It was nice talking to you.
Yeah, it's nice too. Thank you for the essay.
Yeah, no problem. And hopefully it can help you out when you like start your own essay and you get some inspiration on that. Maybe if you like it.
Uh-huh.
Yeah.
Yeah, it really does help actually.
That's good.
I don't really have a lot of like connections with other people. It's like, hey, can I see your essay? It's like, yeah,
Yeah, they're like, nah, I don't want to share my essay with you.
yeah.
Yeah.
That's funny though.
Yeah, but that's good. You got me to help you with all the like academics, essays,
Yeah,
and like advice and everything. I can help you and my experiences too.
yeah. Everybody in my school like glorifies UC Davis. It's like I'm like, what's so great about it? And it's like, no, it's my school. I was like, okay, they got the merch already, so
Yeah,
that's
maybe it's the distance from them. Like it's very short nearby.
true.
Yeah. Okay, I'll see you tomorrow night, Ryan.
See you
Good night.
tomorrow also. Goodbye.
Bye.
Yeah, sleep tight.